Hello students, let's solve next problem. Find the Fourier transform of f of x equals to e to the power minus mod x. Here the function is e to the power mod x. Let's solve this one. Consider Fourier transform. Definition: f of u is equals to integration minus infinity to infinity f of x into e to the power iux into dx. This is the definition of a Fourier transform. Next we need to substitute f of x. Here we can observe we have f of x is equals to e to the power minus mod x. E to the power minus mod x means mod contains positive and negative values both. Clear? Mod contains positive and negative values. This you can write it as e to the power minus mod x means for first substituting x mod value positive value x. This we have when x greater than equals to 0. Next it is e to the power minus of minus x plus x minus x. Mod x means plus x minus x. This we have when x is less than 0. When x is less than 0, we have minus mod. Or this we can write it as e to the power minus x when x greater than equals to 0. This is e to the power x when x is less than 0. Now substituting. Now you can see that here they have not mentioned any of the interval. Here it is 0 is there. Therefore, let me rewrite the definition like this: minus infinity to 0 f of x into e to the power iux into dx plus integration 0 to infinity f of x into e to the power iux into dx. Next we need to substitute f of x. Here two f of x functions are there. Which one you are going to substitute? This depends on the intervals here. This depends on the interval means here interval, this what this interval indicates? Here x is greater than minus infinity but less than 0. Greater than minus infinity but less than 0. This interval what indicates it? X is greater than 0 but less than infinity. X is greater than 0 but less than infinity. Now here the interval is x is greater than minus infinity but less than 0 means which function we need to put here? This function. Here you can see x less than 0 but greater than minus infinity. Greater than minus infinity to 0 e to the power x into now f of x is e to the power x e to the power iux dx plus next 0 to infinity means greater than 0 less than infinity, right? Then the function is e to the power minus x into e to the power iux into d. Now what we have to do is we need to integrate these functions. Okay. Before that one, let me simplify. Integration minus infinity to 0. Let me simplify the terms. Okay. E to the power x into e to the power iux. This you can write it as e to the power x plus iux because bases are same as the powers into dx plus integration 0 to infinity e to the power minus x plus iux into dx. Minus x plus iux into dx. Next you can see some common terms are there. Taking those common terms, that is integration minus infinity to 0 e to the power x is a common term. Taking x as a common term, we left with 1 plus iu into x dx plus integration 0 to infinity. In this term, let me take minus x common. Let me take minus x common, that is minus 1 minus iu into x. Here I have taken minus x, that means here we left with 1. And from this term I have taken minus x, we left with minus iu into dx. Next we need to integrate this term. Directly we can integrate. Integration of e to the power 1 plus iu into x is e to the power 1 plus iu into x upon 1 plus iu. This is like integration of e to the power ax into dx is equals to e to the power ax upon a. Like this. Here a is nothing but 1 plus iu between the limits minus infinity to 0 plus integration e to the power minus into bracket 1 minus iu into x is e to the power minus 1 minus iu into x upon minus 1 minus iu between the limits 0 to infinity. 0 to infinity. Next what we have to do is we need to put the limits here. Okay. Before putting the limits, let me tell you something, that is e to the power infinity tends to 0 as x tends to infinity. E to the power infinity tends to 0 as x tends to infinity. Means if we substitute x equals to infinity, this becomes e to the power infinity and that term becomes 0. And e to the power 0 tends to 1 as x tends to 0. E to the power 0 tends to 1 as x tends to 0. Right? Okay. Substitute the limits here. F of u. F of u means that is Fourier transform. F of u is equals to, now we are going to substitute the limits. Upper limit 0, lower limit minus infinity. E to the power 1 plus iu into 0. Here what I will do is, I will just take from 1 upon 1 plus iu, I will keep it as a constant. Applying limits for only this term. That is e to the power 1 plus iu into 0 minus lower limit minus infinity e to the power 1 plus iu into minus infinity. Next for second step, taking plus into minus 1 upon 1 minus iu keeping constant, substituting the limits. Upper limit as infinity, that is minus 1 minus into bracket 1 minus iu into infinity minus e to the power minus 1 minus iu into 0. Now I told you, as I told, e to the power infinity tends to 0 as x tends to infinity, e to the power 0 tends to 1 as x tends to 0. Using these rules here, we get 1 upon 1 plus iu into bracket, this becomes 1 minus 0. Next 1 upon 1 minus iu into bracket, this term becomes 0 minus 1. Next this is 1 upon 1 plus iu, 1 minus 0 is 1, 1 into 1, 1. Next minus 1 upon 1 minus iu into bracket minus 1. 1 upon 1 plus iu minus into minus plus 1 upon 1 minus iu. Next taking the LCM, as 1 plus iu into 1 minus iu, this becomes 1 square minus I square u square. That is a plus b into a minus b, a square minus b square. 1 minus iu, here we have taken the LCM. This term multiplying by 1 minus iu, here the numerator is multiplied by 1 plus iu. Minus iu plus iu get cancels. We left with 1 plus 1, that is 2. 2 upon 1 minus I square value is minus 1. Minus 1 into u square, which is equals to 2 upon 1 plus u square. This is nothing but required Fourier transform. F of u is equals to 2 upon 1 plus u square. F of u nothing but Fourier transform of this function. Fourier transform of this function is 2 upon 1 plus u square.